Good morning, everyone. My name is Trinity Porter, and today we're going to be using the Pythagorean theorem in SOCAHTOA. This is the full tutorial, and I'm going to be talking a lot slower so it's a lot easier to understand and follow. So what we're going to do first is we're going to take a highlighter brush, and we're going to look at our question here. A car travels 50 kilometers at 60 degrees south of east. How far south is the car from its starting point? So what we've done here is we've highlighted the essential information of the question. So what you see here, this is a coordinate plane basically, but without all the lines. So we're going to graph our problem on this plane. That's why we highlighted the important information. So let's start. It's going 50 kilometers southeast at 60 degrees. Southeast would be over here, and I'm projecting that it would look a little bit like this. So what we need to do next is we need to draw our two component vectors that we need to find. For the one on the x-axis, we're going to go with green. And for the one on the y-axis, for the one on the y-axis, we're going to go with blue. So what is important, what we need to do next is we need to put our angle. We need to put our angle in this problem. So our angle is going to go here. So this is our angle. I'm going to say this is 60 degrees. We can't quite put it in the angle, but we know this is 60 degrees. See if we can try to fit it in. We're going to put it on top. That's our angle. So now we need to figure out our opposite and adjacent. Which is our opposite and which is our adjacent of these lines? Now, this is the hypotenuse. If there was an imaginary line there, if there was an imaginary angle here, it would be a 90-degree angle, and right across from that would be the hypotenuse. The hypotenuse always looks like this. So we know this is our hypotenuse. Our angle directly over from our angle is our opposite. And the line that does not have a hypotenuse, it's not across from the hypotenuse, it's not the opposite, that would be our adjacent. So now we're going to list what we're given and we're going to see what we're solving for. Our opposite, we don't know our opposite yet. So we're going to put a question mark there. Our adjacent, we don't know our adjacent. So we're going to put a question mark. But we do know our hypotenuse. But there's nothing there, you might say. Well, we have to graph in more of the question. It's 50 kilometers at 60 degrees. There's our degree and there's our traveling line. So that's where we would put our 50. That's where our 50 kilometers is. 50 kilometers right there. Ooh. So our hypotenuse is 50. This symbol, keep this in mind because you're going to see this a lot. This is our angle symbol. Our angle is 60 degrees. So let's look at what we have. We know our opposite, technically, from the angle. We have our hypotenuse, but we don't have our adjacent. So this problem would be a sine problem. We're going to highlight that. As you can see, if we have our opposite and hypotenuse, then it is a sine problem. So please keep that in mind. So we're going to do all our math on this side of the screen. Here's how we're going to write our equation for sine. Pull out a different color. We're going to do sine angle. This angle symbol, remember that when we talked about that? Put the angle symbol and then equal to opposite over hypotenuse. So now you're going to want to plug in your information from here into this equation. So let's get another color. We're going to do green. We're going to do 50, which is our hypotenuse, times sine, and our angle is 60. So we're going to put in parentheses 60 equals O, we don't know the opposite, over H, and our hypotenuse is 50 again. So here's when we start doing the math in algebra. We want to cancel out the 50, so we're going to multiply it by 50 to get rid of it. Then you're going to end up with something that looks like this. 50 times sine 60 equals O. And remember, O stands for opposite. Now, you're going to need a calculator for this next portion. I'm going to be using a standard calculator from Google. But you could also use your phone calculator. If you're on an iPhone, just flip the phone to a horizontal view so you can use the whole calculator. So, make sure your calculator is on degrees. If it's on rad, you're going to get the incorrect answer. So make sure it's on degrees. So what you want to do is you want to put sine 60 into the calculator. If it's a cos, you put cos. If it's tan, you put tan. Sine 60 close parenthesis, and we get 8.660. That's where I'm going to stop. 0.8660. So we're going to write that. We're going to write that in orange. 50 times 0.8660 equals opposite. Now, to get the answer, you put this into the calculator. I know it looks a little bit wonky, my 0. So, cancel. 50 times 0.8660. What do we get? We get 4.3. So our final answer, let's do this in blue, would be we get 43.3. I apologize. 43.3 equals 0. So we know our opposite is 43.3. So let's put that into both parts of our equation here. We know our opposite now, but we still have to solve for the adjacent. 43.3 and 43.3. No, we don't have to solve for the adjacent because all we had to do is figure out how far south the car is from the starting point. If we see the y-axis is south, the car is 43.3, gotta remember to put our unit, kilometers south from the starting point. So that is our final answer. We're gonna write it nice and big, 43.3 kilometers from the starting point. You don't really need to put the SP, but I'm just doing that for demonstration purposes. Look at, oh goodness, kilometers. Thank you so much for watching. I hope this narrowed things down, and I hope this gave a better understanding. Have a lovely day, and thank you.